Good morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Morrow's Algebra 2 class. All right, guys, so we already learned how to graph, just straight up graph quadratic functions. You find your axis of symmetry by using the formula x equals negative b over 2a. You find your vertex by plugging in that negative b over 2a into the function and finding your y value. You find your y-intercept, which is the c value when the quadratic function is written in standard form. You graph its reflection or its mirror image, and voila, you're done. Now, it's going to go through the x-axis. Sometimes it goes through the x-axis perfectly, and it's beautiful, and it's lovely, and everything's sweet, and the world is good. But sometimes it does not, and it goes through in-between points. And then at that point, you're going to have to start estimating, and that's no good either. So we're going to learn how to finally solve for these quadratic equations algebraically. Once you know how to solve for them algebraically, you can put those values into your graph and really make a super accurate graph. So the first skill that we have to learn is how to solve quadratic equations by factoring. But before I do that, I want to review something about linear functions. We know that linear functions are in the form of y equals mx plus b, where m is the slope and b is the y-intercept. That's the y value on the y-axis when x is 0. The y is dependent, the x is independent, m is the slope, and b is the y-intercept. Notice that the degree of this polynomial is 1. There's an invisible 1 being raised on that x right there. That's why it's called linear. And when you have a linear function, okay, the x has a power of 1, that indicates something to you. Okay? That tells you that it has 1 0. What's a 0, Mr. Morrow? Well, if you remember, a 0 is the x-intercept. The 0 is called the x-intercept, the solution, the root sometimes, okay? So for all of these equations, functions, linear functions, they all render a straight line. And this particular red line here, this is a 1, 2, 3, 4, 5, 6. That's an x equals negative 6. It has one x-intercept. Remember, it's linear. X has a power of 1. That tells you how many zeros or x-intercepts you're going to have, or solutions. For this black line, it has one solution here as well. For the blue line, it has one solution as well. For the green line, though, that's a y equals 4, and that has no real solutions. This is called an imaginary solution because it doesn't hit the x-axis. So why are you doing this, Mr. Morrow? Well, the solutions of linear functions are those ordered pairs which make the function or equation true. And the solution of system of equations are the ordered pairs which make all of the given functions in the system true. Solutions are values that make the function or functions true, that make them accurate, that make them real. Okay? For quadratic functions, it's a different formula. It's a different function. Y equals ax squared plus bx plus c, where y is dependent variable, x is the independent variable, a and b are coefficients, which we will investigate later, and c is the y-intercept. Notice that the degree of the polynomial is 2. This 2 tells you, hey reader, there are 2 solutions. They could be 2 real solutions going through the x-intercept, or they could be what's called 2 complex or imaginary solutions. And those occur when the graph does not go through the x-intercept. And we're going to talk about complex solutions later. But I need you to understand that whenever, I need you to understand that whenever you have a polynomial function, the degree tells you how many solutions you're going to have. Some of those solutions will be real, some of them will be imaginary. And again, I promise you we'll learn about imaginary numbers. But I need you to understand what's going on here, what the concept is, and why we're doing what we're doing. When you graph a quadratic function, it renders a U-shaped graph called a parabola. Okay? We know this already. This part is review. If the A is positive, it points upwards, like this graph right here. If the A is negative, it points downwards, like the graph right here. And the points at which the parabola crosses the x-axis, those are known as the solutions of the quadratic function. So in this particular case, this guy right here and this guy right here, these guys are my solutions. Those solutions, okay, the solutions can be described as x-intercepts. They're known as roots. They're known as zeros. Any of those words can be used to describe the solutions of a quadratic function. In this graph over here on the right, my solutions are x equals -6 and x equals 4. Those are my zeros, my roots, or my solutions, or my x-intercepts. Those are the solutions. So when we're graphing, we're trying to find where does it go through the x-axis? Where does it go through the x-axis? Why do we try to find that? Let's say we're trying to find a bridge, and this right here is all water. And I want to know what points I need so that my bridge can be level and even. This is not a guess. This is an actual math situation. That's why we know math, so that we can build things like bridges and walkways and arches and aqueducts and all sorts of good stuff. So we need those solutions. Those are the solutions on the horizontal. That's the goal of quadratic functions. Does that make sense so far? Okay, so you're always going to have two solutions for a quadratic function. They may be real, they may be imaginary, but you're going to have two. Today, we're going to talk about how to solve those by factoring. Sometimes we can find the solution to a quadratic function by factoring and using the zero product property. Sometimes. Sometimes it's not factorable. And then we're going to learn the skill that's called completing the square. We're going to learn the square root method. And we're going to learn the quadratic formula. So the zero product property. For any number a and b, if a times b equals 0, then a equals 0 and or b equals 0. So we must set both of those equal to 0 to find my solutions. For example, if let's say I factor a function right now, okay? And this is my factored quadratic function. X plus 3 times x plus 2 equals 0. According to the zero product property, I must take x plus 3 and set it equal to 0. I must take x plus 2 and set it equal to 0. So my solution would then be x equals -3 and -2. What does that tell you, Mr. Morrow? That tells you that on this parabola, the graph is going through -2 and -3, like so. Of course, that's not accurate. I didn't find the vertex or the axis of symmetry, but that's what is happening. That's what it's telling me. Does that make sense? Yes, sir. Correct. That's step 4, the extra point one. It said either extra points or solve. Thank you very much for learning, my brother. God bless you. That makes sense. Okay, so the first skill we're just going to practice is using the zero product property. Let's say that I have this factored function. I want to find my solutions, or my zeros I can say, or my roots, or my x-intercepts. So I'm literally going to set 4x plus 1 equal to 0, and x minus 2 equal to 0, and I'm going to get x equals -1/4, and x equals 2. What does that tell you, Mr. Morrow? Again, that tells you that this graph is going through 2 on the x-axis and negative 1/4 on the x-axis. That's what it means. Who cares about getting the value if you don't know what it means? This is what it means. Does that make sense? Now, these roots, okay? We had said the word roots before as a solution. Sometimes they will give you the roots of an equation, the solutions have you, and then they want you to find the quadratic function that it came from. Well, that's super simple, boys. Let's say that I tell you that the roots for a particular quadratic function are 4 and negative 1. I tell you those are the roots. What are roots again? Roots are the zeros or the solutions or the x-intercepts. And I want to find what quadratic function give me these roots. Well, does anyone have a guess? Yes, sir.
X minus 4 equals 0.
I am so proud of you, son. Good job. If the root is 4, that means that it came from the zero product property of x minus 4. If my root is negative 1, that means it came from the zero product property of x plus 1. Because if I have x minus 4 times x plus 1, using the zero product property, don't I get 4 and negative 1? So now what happens? I need to turn this into the quadratic function that it originally started with. So what skill do we use? FOIL. You distribute. You not distribute, you FOIL. So x times x is x squared plus x minus 4x minus 4 equals 0. So x squared minus 3x minus 4 equals 0. And that's the equation that these solutions came from. Sir, sometimes they will give you the roots, and if they say the roots of a certain quadratic function are 4 and negative 1, find the quadratic function, you go backwards. The root of 4 goes to x minus 4 times the root of negative 1 goes to x plus 1. And now you FOIL and you get your quadratic function. Sir, if you're given the root 0, that means that it's just x. Right? Because x plus 0 is 0, right? So that would be something like you'll have a function that it'll be x, and then let's say x minus 2, for example. Let's say the roots were 0 and 2. It'd be x and then x minus 2. And then you FOIL that one, and it'd be x squared minus 2x. Thank you. Great question, son. Okay? Does that make sense? Okay. So, what are the solutions to each of these equations? This should be really simple. You're using a zero product property. So x is going to equal negative 1 and 5. Again, what does that mean, guys? What does this negative 1 and 5 mean? They're the solutions. This is where the graph goes through the x-axis. Thank you. B, n would equal 2/7 and 4/5. Very good, my brother. C, x will equal negative 1/2 and negative 14. Very good, my brother. For D, x would equal negative 3/2 and 4. That's fantastic. All I did was set each of these equal to 0. So I went 7n minus 2 equals 0, and then I just did the work. You should be able to do that work pretty quickly. If you need to show yourself steps, God bless you, there's nothing wrong with that. Does that make sense, gentlemen? Promise. May I continue? Now we're going to do the whole thing together. Okay? Now I want the actual solution. So I'm going to factor. What you got there, kid? x plus 3 and x plus 5 equals 0. Zero product property. I got to set x plus 3 equal to 0 and x plus 5 equal to 0. And x will equal negative 3 and negative 5. Makes sense? Number 2, we're going to factor p plus 5 and p minus 4 equals 0. So p equals negative 5 and positive 4. Those are my x-intercepts. Those are the values through which the graph goes through on the x-axis. That makes sense? Number 3. Very great. Great job, sir. Great job. M plus 2 and m minus 7. So m will equal negative 2 and positive 7. Those are the x-intercepts. That is where it goes through. That is where the graph goes through on the x-axis. And last but not least, we're going to do a little Cuban method. So we got 2x, 2x, 2 times 18 is 36. What times what is positive 36, but when added together is negative 15? Negative 12 and negative 3. Thank you. Imaginary factor of 2. So I've got x minus 6 times 2x minus 3 equals 0. So x equals 6 and 3 halves. Those are my x-intercepts. Does that make sense, gentlemen? Questions so far, gentlemen? Promise? May I continue? All right, what are the solutions? Okay, we're going to get a little tougher now. So first off, I got to bring over this 18. Okay? So I'm going to get 4x squared minus 21x minus 18 equals 0. Cuban method, 4x, 4x, 4 times negative 18 is negative 72. So what times what is negative 72? Wow, great job. But when added together is negative 21, it's positive 3 and negative 24. Imaginary factor, 4x plus 3 times x minus 6 equals 0. My roots or my solutions, my x-intercepts are negative 3/4 and positive 6. Number 2, what times what is negative 54, but when added together is positive 3? Excellent, son. Excellent, sir, as well. Excellent, gentlemen. X plus 9, x minus 6. So x will equal negative 9 and positive 6. For this bad boy over here, I got to add 49 first to both sides because before I can factor, I need to make it into a quadratic function. So what times what is 49, but when added together is 14? Plus 7 plus 7. This is called a double root. X equals negative 7 and negative 7. But do I need to repeat the same number twice? Nah. So it's just like this. Now, a lot of people ask, how does this look though, Moro? Well, this means the following. That at negative 7, it's positive, so is it going up or down? So it's going like this. In this particular case, that's going to be your vertex. And my y-intercept would be positive 49 way up high. Sir?
Let's say you would have found the vertex without calculating. Would you get the same answer?
Yeah, of course you will. If you wanted to find the vertex on your own, we got negative, well, my axis of symmetry is negative b over 2a, which is negative 14 over 2, so x equals negative 7. That's my axis of symmetry. Plug that sucker in, and what are you going to get? You're going to get, if I have negative 7, I have 49 plus 49, which is 0, And then, come again? Oh yeah, I'm sorry. I'm a fool. 49 plus 49, and then you have plus. Actually, wait, no. This is not necessarily going to be the vertex. Actually, that's wrong. Whoa. You are going to have one solution, but that's wrong. It's not going to be like that. It's just going through it one time. Let's see what it would be. Negative b over 2a is negative 7, right? My vertex would then be negative 7 squared, which is 49, minus 14 times 7 is, oh no, it is going to be right. Negative 98 plus 49. Yeah, that's 0. So no, I was right. I don't know why I was second guessing myself. So it's going to be like that. It's a solution. Okay? Last but not least here, Cuban method, I got 2x and 2x. 2 times negative 36 is negative 72. What times what is negative 72? But what I have to get is negative 21. Plus 3, negative 24. Imaginary factor of 2. So 2x plus 3 times x minus 12 equals 0. So x equals negative 3 halves and positive 12. And again, those are my roots, those are my zeros, those are the points on the x-axis. Those are the points that are intersected by that parabola. Does that make sense? Okay, now, I got a couple minutes left. We're done with this. But let's put it all together and show you where this is going. Remember, this is just one way to solve. If it's factorable, right, my brother? If it's not factorable, we're going to be learning different skills. But let me show you how this is being put together. Let's say I tell you, solve by graphing. If I just say graph, you don't need to explain the x-intercepts. But if I say solve by graphing, you're going to have to really show the x-intercepts. So let's say I tell you that f of x equals x squared. Let's do something nice and easy enough. Minus 5x plus 6. First thing we're going to do, axis of symmetry. Axis of symmetry is x equals negative b over 2a. So x equals 5 over 2. So x equals 2.5. Remember, life isn't always a beautiful whole number. Number 2, vertex. Vertex is my 5 halves, comma, let's plug it in. 5 halves squared is 25 fourths, minus 25 halves plus 6. I got to get common denominator of 4, so this 2 goes to a 4, this 25 goes to a 50. Thank you, my brother. 25 minus 50 is negative 25 fourths plus 6 over 1. That goes to a 4. That goes to a 24. So that equals negative 1/4. So my vertex is 5 halves, comma, negative 1/4. What's my y-intercept? Very good, my brother. 0, 6. And now that extra point is not needed. We know how to solve, especially this one because it's factorable. I got to find my x-intercepts or my solutions. So I've got x, what times what is positive 6? Point out together is negative 5. Negative 2 and negative 3, so x equals 2 and 3. Now, guys, let's put it all together. You'll see how easy this really is. So, you ready? Let's do this. My axis of symmetry is 2.5. My vertex is 5 halves or 2.5 and negative 1/4. So it's like right here. Mr. Morrow, how do you know that's accurate? It's not. It's an estimate. But it's okay because you have the values right here. So as long as it's in the ballpark, you're good. My y-intercept is 0, 6. 1, 2, 3, 4, 5, 6. That's 2.5 to the left. So go 2.5 to the right. So here's a half and then 1, 2. Now the part that makes it all beautiful and perfect. My x-intercepts. I've got an x-intercept at 2 and at 3. And now that's an accurate graph. Does that make sense what we're doing, why we're doing it, and how we're doing it? Any questions before the bell rings, guys? Because I want you to be able to do this homework with ease and awesomely. Well, I hope you learned a lot. May God bless you. Thank you for a great class, and I'll talk to you on the flip side, y'all.